Hello and welcome. My name is Nathan Davis. This is the first YouTube video I'm making that I'm posting. And I'd like to talk about jettl, the two-thirds of it, the events and messages. And queues come for a different set of videos. There is a lot to unpack. I have been working on this project for a little bit of time over the past year. Mostly recently, I've gotten a lot of inspiration, and I've been programming LabVIEW for 2 years. I learned Actor Framework early on when learning LabVIEW. I was intrigued with object-oriented design, and Actor Framework was perfect for me, and I thought the world of it, and I still do. I use it in all of my projects. There were just a few things that personally I thought I would try my hand at to improve, at least in my mind, from watching many videos and reading many forum posts by Stephen Loftus-Mercer, Alan C. Smith, Dimitri, Darren Nattinger. There's so many people who have made great posts and videos that I've learned from. And these collections of ideas, I tried my hand at creating my own framework. So thank you to the community for everything that you put in. That being said, because I've used Actor Framework for the last 2 years, well, 2 years and 2 months, I'm looking at the date now, I have a lot of inspiration from Actor Framework. So a lot of what you see, if you are currently an Actor Framework user, it'll be very easy to pick up the contents of this video. I'd like to keep it light. I currently have this cloned into my computer from GitHub, and this is the main project. I will not go into it in any depth, but all the source code is right here in the central project. And if you're curious, you can go to the jettl Discord page. It's under my name, NateV51. This is me, the Velma icon. And you can fork it, clone it, play around with it. Currently it's not on VIPM. You have to build it from the source code, both the build file here in the jettl folder and jettl tools. Build the jettl tools mock. So I have to figure out the VIPM. I've tried, but I wanted to get the video out. So this will be on VIPM soon enough. That being said, it is all written pure LabVIEW. Nothing's protected. I actually don't think anything is protected. There are no X nodes, no malleables, no PPL support, which I'm not focusing on. I watched a great deal of videos and things from Alan on Actor Framework, read documentation on the project provider, and checked out that source code. Holy moly. It is intuitive enough. I decided to go with right-click menus myself for 3 preliminary tools. So no project providers either. It's just tried and true LabVIEW. So feel free to explore if you'd like. I will not stay in the project. Instead, what I'd like to do is go through an examples that show off some of the main tools that I have developed with, again, a lot of support from the community over the years. I've just read a lot of forums and checked out a lot of open source projects. So really, some of them are my ideas, but a good deal of them I've gained inspiration from other projects, but put a lot of twist on them to make them my own. But nonetheless, it's not only me. If you would like to contribute, feel free to give me a pull request here on the GitHub. I can keep talking about the high level, but let's get into it. Let me show you just some core jettl functionality. It is a framework, and as any project, we're going to start LabVIEW. Go back to the desktop. Oh, I should say two. This may be a long video, so feel free to scroll through it. You don't have to watch the whole thing. I appreciate you watching it in the first place, but I'm going to be rambling and going over a lot of concepts, keeping it light, but deviating, maybe without knowing it, to advanced concepts. So, yeah, if I misspeak, forgive me. When I create a project, I have a central main file, rather main function, and we'll keep the execution to non-reentrant. And I think one of the best ways to learn any source code is from the palettes. And you will not see me use the palettes a whole lot, but for introductory things I may drag and drop just to show you where things are in the project in the palettes. But this is the jettl palette. It's separated into two sides. You have this queue side where you create a base queue and the queue folder with all the queue functionality, and the event side where you create a base event with the event functionality. We will not talk about queues today. I might have mentioned it already. This is where the true magic happens. And before the magic, get some fundamentals down. The queues is really what leads to a distributed system. And we will focus on only one actor, just the event actor, and only one event actor at that. Not two, not three, just one. But you can link these together with queues, in short. So what you always do at the top level is create a base queue, and immediately you'll see the dependencies fill up with the necessary libraries that you had seen earlier. So the main jettl library, and then some base messages that the event implements. So the two required inputs are the self-event alias. It is required that you give an alias, so say hello world event, say alias. And then the object that you would like to create as an event. And because this comes from the interface event, you won't have to do anything. Let's go to the tools, because we need an object to create our application. So under the tools, so the tools pull down menu and jettl tools mock. Presently, there are three tools: the template, a renaming tool, and a rescripting message tool. Looking at the template, there are three flavors. There's that queue in the event. We'll only focus on the event. and then a message strategy. This word comes from the strategy pattern, which this might even be more advanced and it doesn't matter, but this is what leads to dependency inversion, inverting the dependencies to abstractions. And each of these three types have a main template. So we'll start with the template event and create. In the background, you'll see the project is populated with the template event. This template is what I call the name, and the class has the same template event with the pre-populated methods that you can use. And on disk, it comes in a folder with the library and then the class with all the necessary overrides that we will get into shortly. For more advanced purposes, this is presently marked as a private class to the containing library. I'm going to change that to be public, and we will get back to it later. So instead of this event interface, we have this template event that comes in, and without going into any hard details, this right here is the template event. You can see it right below, template event, library, template event class. It implements the event interface. So you see that there is implementation here, which is why this is a valid wiring. So, before we move on, the renaming tool. Renaming gives you a drop-down of the different types detected in the active project and their associated names, and a field where you can rename. With a few things of logic behind, you can't give the same name, it'll close you out. There are a few other bugs I found, but nonetheless this works if you're really trying to make it work. If you try to break it, it'll break. So rename, and when renaming, you'll see that, I'll let it save first. In the project, this is immediately saved, the library is changed and the class is changed. So the name that you rename Hello World has this ending like identifier event still attached. This is meant so that the tools can find the different classes of these different types. It's one of the checks. The other check is finding which classes implement which interfaces in the hierarchy. There are multiple checks to ensure that this class can be renamed, you know, that it's in a containing library, etc. And also on disk, Hello World event, the library, Hello World event, the class, and Hello World event for the class name as well. What you'll also notice is, we'll get to all the methods. Say this decorate method, the objects for the dynamic dispatch input output have been changed accordingly to Hello World event in. Beforehand they were template event in out. So all of these have updated accordingly. And to encourage a kind of continuous refactoring, you can rename any type of class, library. I'm getting blown up on Discord. Any library or class while developing, you can rename. Now I think I have to speed it up because I'm probably spending a bit too much time. Okay, let me turn this off. I don't know how to turn it off. Hey, this is uncut, so here we are. I see you, Grayson. So that's the renaming tool, and you'll see me rename in the future too. I have a few examples I have planned out. So getting to the contents of the event, the Hello World event. Change the banner as well, just so. So this will probably be here for you to see. Hello World. You know this is an event decorator for from the object name. And let's get into actually instead just for proper data flow. And we will clean it up. Alright, needed to save that due to the rename. Let's see where to go from here. I suppose this works out of the gate without knowing anything about the functionality. This create base event, you wire in the event, and I will run it. And immediately you have this window that appears with a little comment about VI properties and sending panel close event to tear down. This is the base functionality where if you hit your panel close, see the library is locked, it'll release the references, closing the application. So this works as a user interface out of the box. The heart of everything, oh gosh, maybe I should back up a little bit too, just to show what all is going on in the two folder structures. So let me open up the main, and I will minimize this. So create base event is kind of the first way that you create an event if there isn't presently a creator in your system, which there isn't. And the main event palette right here gives you all of your dynamic dispatch that are found in the Hello World event class. You'll see the different colorings that I'll talk about a little later as well. These are broken up into libraries, so functions within libraries have this purple banner for the library's name. These are all message strategy, and the blue are interface methods, which are all currently dynamic dispatch. And green, you'll see here from the class, has this green wire with a green banner. That's a class. So the way I think about it, or justified it to myself, is that green is like green grass. It's at your feet. Low level concrete implementations, green class. And then blue sky. So you look up, you have your higher level behavioral methods. And purple, it's cheesy, but it's like a, your galaxy, your universe that encapsulates, your world with the sky and the grass and the da-da-da. So 3 main colors presently for the library: purple, interface blue, and green for the class. And I will keep the palette down here. And to show, there is the jettl and the jettl utility virtual folders. Now, this top row and then this third and fourth row here are in the jettl virtual folder. And this bottom portion, these methods here, are the utilities. So looking at the jettl folder, you have this top row, which in order you have decorate, routine, VI, server setup, etc. Right here in order. And these are a part of like the algorithm for execution unconditionally. These methods should not be reused. You first decorate, you go through your routine where you set up your VI server, get registration for events, receive messages, handle them accordingly. You destroy at the end, and then any remaining messages you can handle how you'd like. So that is the first row, and then the third and the fourth row are the messages, which is in this folder here. So you have setup, teardown, merge, and override error. Last acknowledgements from your creator queue, which we won't get into today. We won't receive it. And then setting a panel state to be hidden, standard, etc. So these are the methods that are executed. And these are the messages that are sent to execute these methods. And the jettl utility has kind of this base functionality. This is where you can reuse your code. I should say too, for the messages, you can use these methods anywhere in your class. It isn't necessarily just for executing messages, as we'll see later. You can use these methods anywhere. It's just that these ones here between decorate and remaining should not be used. It's not enforced, but they shouldn't be used. But these messages can be. Further, code reuse is in jettl utility, where you have self-event alias, so to send messages to yourself to get your alias, and then miscellaneous ones like getting an error, overriding to nominal states, etc. Serialization, and then some advanced ones, which are here on the bottom right of the palette, which I will not even talk about these. These are more advanced that lead to the distributed system design with the queues, and we do not have a creator queue. We only have an event that we're creating. So all of these, they're very important. I'm not going to even touch on them. So that's the organization of the palettes with the project, how you see it in the template. And the heart of everything comes from this routine method. Maybe I should back up. The heart of it really comes from this base event class called actor event. Let me get rid of the palettes for now and drag this up here. Really, it's not routine, it is this actor event that is this asynchronous process. And for those who know Actor Framework, you'll see a lot of parallels between I believe it's called the Actor VI. This is the Actor event because there are two flavors, events and queues for jettl. And it can be broken up into initializing some references, hitting that decorate method. So decorate is the first one in this algorithm of events. So decorate, setting up some more references, and then hitting routine. So hitting routine, and then inside of routine are all VI server, setup, registration, receive, handle, destroy, and after routine is remaining to take care of the remaining messages, as well as releasing any references. I think I said references here, handling messages, and then at the very end, sending last acknowledgements to the creator. So you have decorate, hit the routine, and remaining. So decorate, this is the whole routine, and then remaining. So it flows like this. And this is the heart, really. This is more so the heart of it, the routine. And routine sets up your VI server with this application and this VI. And depending upon what occurs inside here in this override method, you see if you're still in the nominal state. If you are, go ahead and get your registration for your events and continually receive the message and execute the message, handle any general things after a message is executed or event in general. And then if you're still in the nominal state after handle, go ahead and loop again to continually keep checking out messages until you're not in the nominal state. And unconditionally, whether you are in the nominal state after VI server setup, you unconditionally execute handle. You can see it here, it's in both cases. You always handle and followed by the destroy. So you unconditionally handle and destroy. And then afterwards, you go to the remaining. So the first thing that occurs in Decorate is, oh, maybe I should back up just a little bit, So this is what's happening in the background is decorations of methods. And you can see them firsthand. Say in the handle doesn't have any functionality. Outside of this wrapper method where you take the in-place element structure, and there's only one data type in the class called the event, and it's that event interface. And at runtime on the object's wire, it's not the event interface, it's actually the base event, which is from the dependencies. It's this class here, the base event. But you don't have to worry about that. You just know that internally there's some functionality that's abstracted away from you in handle. If you're curious about it, you can double click and you can look into the base event class. Actually, handle doesn't have any functionality. Actually, most of these don't have functionality. It's mostly the utilities. But nonetheless, every single dynamic dispatch is a wrapper for a method in for the base event. So there are wrappers everywhere. Some of them only have dynamic dispatch input, not an output. And you can see that here. This is just a get registration, which occurs right here. So you're only getting the registration, you're not necessarily passing the object out, saying that you're manipulating it in here. You're just getting the registration. So every dynamic dispatch here is a wrapper, and you don't need to know anything about the internal functionality. So let's go back here to Decorate. Decorate, you send a message to yourself, the self event. Let me bring the palette up once more. Pin it. Here's the event palette. It's the same as the project window, but just so you can see here too. So the self event is one of the utilities, and it's wired here. It changes implementation depending upon the wire that the object that goes in. So right now it's an interface. You connect to the class, and it changes implementation to hello world. So you send a message to yourself. You are an event, so send it to yourself, and you're going to send the setup message. Here are some of the messages that come with the event palette. You have setup, teardown, merge, override error, and then setting the panel state. Setting the panel state, can be standard, closed, hidden, min, max. So this is the sending setup to yourself. And you see it's done in line with the object wire. So after you send the setup message to yourself, you send the set panel state to yourself as a standard to display the panel. So let's decorate, that's the base functionality. And after decorate, executed is the routine method, which has several other methods inside. You have the same wrapper here for the routine. And here, open this up, the VI server setup, it bundles in this application and this VI to the wrapper method, and then you get this VI, which is your another utility. Get this VI where you can get what you wrapped in here. And it's just to open the front panel. So note, I should say this too. You sent a message to yourself, but you haven't executed. So you've sent a message to yourself to say, hey, put the panel state into standard, set up. But you haven't executed the messages yet. So you get the VI reference, which is the routine, which is your panel, and go ahead and set it to hidden, and then you can merge the error. This is the first example of, utilities are made for reuse, but so are the messages implemented methods. So merge error, even though it comes as a message that you can execute, you can also use it on its own in methods of the class. So this is where we merge the error, and internally it's exactly how it sounds, where you merge the error existing internally to the base event, you merge the error, and then you see if the error is because you can merge in a constant error, and if there's already an error, if there's not an error currently in the object wire, and you input not an error, you actually don't have an error, you're in the no error state. so you don't have an error, so don't change the internal state. If there is an error, change the error state. There are 3 states. There's the error state, the teardown state, and what you'll normally be in, the nominal state, which coming up is nominal state, returns a boolean if you're in the nominal state or not. But going back to VI server setup, you merge your error back. You can do this for serialization. If you truly want serialization and you don't care about the error, what you can actually do is use another method called serialize to inputs, which simply just has a lot of variants as inputs. You wire any data type, it doesn't do anything internally. And it serializes the object wire to the input. And I believe we'll go over an example a little later about how that is implemented. But nonetheless, you can. I want to use quick drop just to serialize to inputs. Just to yeah. See, I could drag and drop and then rewire, but quick drop is way easier to use. So let's say that you didn't want to necessarily. Yeah, I suppose we'll return to it. This should suffice for just merging the error back in. But if you don't care about the error, but you want to ensure data flow, then you can serialize with the inputs by using this other method here. And the next part, I didn't outline it earlier, but the alias we gave, the self event alias that we initially gave in the main, which is here, the hello world event alias. We get that alias by using this utility, self event alias, and it gives us that alias we put in, and we get this VI. So we have the routine method, and we say make the front panel window title, this alias name, and then I merge error. And even here, if you don't care about the error output, you could just not use this at all. I don't want to clean up the rest of the wires, so I just delete it. You could very well do that too, just in case there's an error, I suppose, or if you want to optimize code, then you don't need to merge errors. There are a lot of optimizations you can make. I'm just trying to make it foolproof enough that if there is something that happens, it'll be detected like an error. So this is VI server setup. The next is if you're in the nominal state. Really, we won't even think about too many errors in the course of this example. We won't expect any, really. But you'll always be in the nominal state unless you send a teardown message to yourself or execute teardown in line, or if there's an error where you're in the error state. So if you're not in the nominal state from VI server setup or that decorate method here, then you won't go through message handling. You'll just immediately execute this handle override and then destroy. Now, I want to keep going back to the, I probably shouldn't. I want to go back to the jettl library to show where registration, I will do that. This will be useful. Actor event, which is what we've seen. Now let me move these again so you can see. So here's the routine method. This is the routine override. Cancel that out. So when you launch the asynchronous process, you're going to create this self event create, which under the hood creates a message queue. Message event DVR. So it's a by reference. And then because you have a message event DVR, you take that as an input and then create a user event out of it to get the registration. And that registration is goes down here, this wire, into the init method, which bundles into the private data of base event. Is that confusing? Maybe. Seeing it for the first time. And then at the end of routine executing, you unregister for your events here, and then get the remaining messages. Anyway, so get registration occurs here, where you get your registration. All it is just a get registration from that private data base event. That's where it comes from. And I think this is the last time I'll look at this. Who knows? So returning to the routine, you get the registrations, and then from before in the decorate method, we've already sent to ourselves the setup and the set panel state with this input of standard. So the first event is executed, and it's guaranteed to be the first event that is executed. We haven't shown the panel yet, so there aren't any other events that could execute before. You know, it is guaranteed that setup occurs first, followed by set panel state, because events are first in, first out, FIFOs. So that setup message receive is just a dynamic dispatch for you to, look at the message that is going to be executed. If you want to log it, if you want to this could probably be useful for any kind of debugging. But right now, no functionality, it just passes the message from the input to the output. And then here is the core of the strategy pattern. Call it the message strategy. This interface called message method, where depending upon the message you put in, you dynamic dispatch into, and if you know Actor Framework, you know this pretty dang well. This is only with interface messages though. So let's see, where's the one that I give the homage? It's here somewhere. Oh, that's right. It's in the queues. Anyway, I have comments about, why things occur here in a different method. You see the wiring's jank, but Basically, your message comes in with the necessary data, let's say from the set panel state, where we set it to standard. You unbundle that to the necessary inputs. You know, yeah, there's way more to talk about there, but this is where you execute the messages method. I could really talk a lot about this. This is an awesome, awesome pattern that I did not create. This is all Actor Framework. I just touched up a few different things, such as you see there aren't any errors on the methods, the method being executed. There's only for all of them, it's standardized dynamic dispatch input output. And then if there is any errors, it's internal to the object's wire. And you know, if the message that you send to an actor cannot implement that message, you say there's basically an error, and you merge that into the object's wire without executing the method. There's so much more to talk about there. Great pattern. And then after any of the events that execute, you handle, and then say there's an error, you know, handle, you can, here you can, I'm just going to do this because quick drop is much easier. I should be even better about, boop, boop, boop. Oop. Not looking good. So, ooh. If there is an error and you handle it, you know, this is where a prime example of the override error, what I should do too is just say override, not the message, override error, the method, and let's say you know, clear, oh, curve. So you clear errors, and you can override, something like that. You know, the necessary error is your timeout, your so this is the use case for override error, is right here in the handle error. Handle error in the handle override, which you can handle errors here, or you can do anything here. I will wire this back. And then unconditionally, you always destroy. And any messages that remain, you can do as you wish with them. This is kind of the analog to, if you look at Actor Framework, you'll notice this is the drop message method, I think is what it's called. I just call it remaining. A lot of these have similar parallels. I just changed a few of the names, actually most of the names, just to reflect how best I see interpreting method execution. Let's see. We haven't coded anything yet. This has just been the walkthrough of what this is. So let's see. I think we should start coding now. Do some programming. Maybe I should back up to a little bit. No, I think we get the basic gist. Let's start programming. Oh, no, we don't. The other event that is auto-populated, there are two. There's the event to message strategy, and there's also a panel close. Ah, yes, this is what I want to talk about. So panel close, you discard the event, and for the default behavior, default behavior on panel close, you execute the teardown method. Now the teardown method, if we look inside, this is just over here. What happens in the base event is you simply bundle in, or rather you like override the state to be the teardown state. That's it. So you bundle in the teardown state, and then is it a nominal state? It's going to be in teardown, so then you exit the loop and destroy. This is what teardown does. Now another thing we can do, instead of just executing teardown, I'm going to bring up the, I like icons, easier to see. Instead of just executing teardown in line, we can also use the self event. I'm going to use quick drop. You can see this is the same. We're going to use the self event to send a message to ourself. And that message is going to be the teardown message. And functionally, this is the same as executing teardown in line. It's just that instead of executing teardown in line and then going to handle in nominal state exiting, it sends a message to ourselves. So it handles in nominal state we still are, because we've only sent ourselves a message. And then the message gets executed here in the message override, and then handle is nominal state. No, we're in teardown, because we just executed the teardown message's method. So we exit the loop. Just going out to run it again. And we close, panel close, send a teardown to ourselves, application closes. But immediately, if you want something to be done right now, you would revert back to the teardown method, and I will do that here. Is this it? So now we've talked about the comment modified for UI window settings. This is just default here for the window appearance. These are the settings. Pretty straightforward for main window UIs. I guess there are a few things that are on my mind, but let's just code. I'm going to delete the comment, and I'm going to put down a button, and let's call it display hello world. I've kind of practiced, but I really haven't practiced this, so this is very uncut. So display hello world. What I tend to do, and some that I've seen don't like this methodology, I create an event value change, move it right here, and I have this little note. Bundle in front panel references. So anything that's on the front panel, I will bundle it right here. And the first reference we have on the front panel is display hello world. So we're going to get the reference, create the reference, put it in the private data for the hello world event, and we're going to bundle this in. I need to get better at keyboard shortcuts to make it quicker. So bundle in the reference here. Now it doesn't do anything now. We don't use the reference anywhere with property or invoke nodes. Instead of display hello world, instead we're just going to execute the teardown just right now. So when we click the button, we'll execute inline the teardown method. So we'll run, and then we could say X to close normally, or now we have functionality in this button press to also tear down. But instead of tear down, we're going to send ourself a message. And do remember that the first two messages here, at least, you can add more or less, are going to be setup followed by the set panel state. So those are the first two events executed. They're both messages. And then if we want to send another message, this will be the third message that we send in the sequence. Other events can happen too. You know, like panel close could happen as a third event. Or display hello world can happen as a third event. But let's go to the third tool. Oh, not quite yet. Go to the template. Go to the message strategy template. And there's so much I want to talk about this too. I will not talk about it too much. I will immediately rename it. I need to change to message strategy. Hello world. It'll suffice to say this right here, the hello world, you won't touch this function, but it is what you send, just like the set panel state or the tear down. This is your function that you're going to send. And you will never edit this. Same with the class. You will never edit it. It's private for a reason, internal to this library. What you will change a lot is your interface, to program at an interface, not at concretions. So what we'll do here is we will change the, what did I call this? Did I call it hello world? The hello world. I did. Hello world. So this is the icon. And that is it. If we want to use this hello world, you'll see this icon is still blank. So now the third tool, after template and rename, is the message, or the rescript message. It finds all the messages in the active project. Notice that the other messages that like tear down setup are not here because you cannot rename them. They're not active in the project. This is only the hello world. So when you rescript, you'll see this new icon is here that matches the interface icon. Interface methods icon to be hello world. And now this is something else I would like to script. You could send the message, but you need to be able to implement the message. So the hello world message strategy. And now you need to override the message. And I save it really quick. And from here, this hello world, it is a message. It is a jettl message. And I put it in the custom folder. So it's easy for you to find. This is a custom message right here. And right now, it has no functionality. We will give it functionality with a one-button dialog to say, hello world. And you'll see, too, this is shared clone reentrant execution natively. So if you spawn multiple of these objects and execute this method over and over across all of these different objects, the shared clone is there. So you're not waiting for another actor to finish executing the method. You know, if you have 10 of these objects, you don't have to wait for one of them to execute. They're all shared clone. So hello world. We send that message to ourselves. When we click the display hello world, it gets executed here in the message. Then we handle and see if it's still in the nominal state. So we'll run the app here and display hello world. Hello world. And then panel close, closes the application. So hello world is good. Another thing I'd like to show with the rescripting message is any data that you want to send. So this will be, we can call it a string. It is a required input now for the hello world interface, but it's not reflected in the function. So now keep your eyes on the function itself that we have here. If we go to rescript message, and we say hello world, and we rescript, you'll see now it has a string input. So greetings. And now one thing I haven't done yet, you'll notice there is an error. The error occurs at this, the implemented interface, the implemented method from the interface. It doesn't update, so right now you have to do this manually if you rescript. But that'll be done in the future. It's too important not to be done. So in the routine, now we can send the greetings string. So when we're in main, we say greetings. We'll close. And now let's get a bit more fancy. Now we want to be able to put a string control down and say hello world string. You'll see the spacing is nice at 10 for later when you use the pain relief from Hope. So now, 10 is just easy to see. I lost my train of thought. 10 is just an easy increment when you're resizing things. It's really easy to see, your proper spacings. I won't use it here. But now that we have a control, create an event case. And we'll get the reference, put it in the private data. This can be rescripted too. Tom McQuillan's already made a tool about this that I was thinking of rewriting to best suit what goes on here, but didn't have enough time. I wanted to get the video out. I couldn't. I will do it, unless somebody else wants to do it. I've already read his code. It's open source, so I'll use it. Use his toolkit if you post it on VIPM. Let's see, or maybe he has already posted it. Anyway, so bundle in the reference here, hello world string, and I just do that just because we might use the reference in the future. And here, we're actually going to copy the string itself. Oh no, naming conflict. This is probably better practice too. And I consider making this default, but suppose you do it how you'd like. We'll put this in a refs cluster. We'll change the ordering to have refs at the top. And then these are going to be incorrect, so we will change them as they should. And now here, from the private data with the string, we will bundle in immediately the control. And when we send ourselves a message, instead of greetings, will be dynamic, so that when we run, we could say Nathan, display Nathan. So this is internally bundled to the class private data. If I just say does it work? Yeah, it does. I didn't recall if, and then you can close the application. I didn't recall if you. Yeah, that's right, because every value change it updates, not just when you click enter, because enter is also a character. Then we'll be in the control settings. Let's get more fancy too. I'm going to make another message class. It's pretty common to iterate through data sets. I might go silent while I program. Now it's not the framework level that I know really well. It is the more LabVIEW style, where I have to concentrate a little bit more. We're going to show some type of wave form between 1 and 1. And I can do this, but it's okay. And now tedious. Create a reference, get the control. Put it in the private data under refs. And I hope you start to see a little bit of the benefit of using these events with messages. Now, you can't create an event here from the right-click menu, so you need to create instead an event here, which I don't think I'll use in this example, but it's just here for housekeeping. When you execute a value change from the signaling of a property node, this will execute. Or, yeah. But I won't use it. It's just here for housekeeping, so it's not floating around the indicator. And we're going to send a message to ourself. So we're going to create a message. And now I can flow. We'll immediately rename the message strategy template to iterate. Sure, why not? Oh, I suppose I could say too, this is saved. So iterate message strategy, it's here on disk. It's got everything properly renamed in the folder structure. You don't worry about a thing. It's all done for you. So, power of scripting. If you can do it in your project, you can script it within reason, within the my computer target, I think. There's other things too, like runtime, but I don't know enough about that yet. So in iterate, for the most part, I'll do two things. I'll change the icon name, and then I'll also have some type of data. Iterate. What am I doing? Let's change the representation to an I32. And clean it up. And rescript. Rescript iterate. Now you'll see the function updates with the proper input. And before, actually, let me implement and then show you a best practice. Here's the message. I'd like to make a tool for that, just like a screen that has the different, say, for example, the events, and then what messages they implement, and then what messages you'd like to add for them to implement, and then immediately do, you know, the implement from this message interface, and then override the proper method name like I'm doing now, and then put it in the proper custom folder. That way you see, you know, immediately these are the messages that are customized that this event can implement, the hello world and the iterate. Let me show you a best a best practice. So here are the three libraries we currently have. The hello world isn't being sent from anywhere else, or is it being implemented anywhere else? Actually, it's only in the hello world event. So this private messages folder is where this library would live. So I'll drag it in here. And now the library is private. So if this function were to be called anywhere external to the library, it would throw a compile time error. So you know that this message is only being implemented and sent here in the hello world event. That's very powerful. And if you'd like to change it to public, there should be a tool for this too. You change it back to be outside of the containing library. But let me show you. It should be private, and then what I like to do, I do like text. I'm going to change this text to red instead of black. And in the routine, when we call the hello world message, you see it's red with the as the text in the banner. So red means that this is, remember purple is a library, so now this library is marked private, so it's private to this containing classes library. You know that just because of the file structure. So this is a private message. Super easy to tell. I don't think you need to second guess it. Whereas over here, oh, I actually haven't done it yet. Over here, when we send iterate, it's public. But even this one, I'd like to make it private. Before that, we moved the hello world message strategy to the hello world event. So what we also should do, like I said, this should be scripted. I'm going to move the folder structure to the hello world event. And it says, what are you doing? There are dead folders after I move, so I'll delete those, make sure they're empty. And now you'll see on disk, under the hello world event in the library, there are these two containers. There's the hello world event class and the hello world message strategy library that are both in folders right here. The class and the library for the message. And we'll do the same with the iterate message as well. We'll make it private, and I'll change that. You'll see it here, the message strategy. I change the icon to be red text and updates. So now you know this is private to the Hello World event and any other classes or anything that is contained in the Hello World event library. And now I must change this on disk as well to be internal here. Okay. And these are dead folders. So I delete them, and now you have the iterate message strategy in the Hello World event library. Same directory path. Okay, good housekeeping. Now you don't second guess anything. So what I'm going to do here is I am going to say we're going to get another iterate once. Give it the same label name. Oops. Save the label name, take it off. There it is. And now script. Get the reference, put it in the class private data. It is a control. I will make a value change, put it up here, iterate once. Now the iterate. I could send a message to Sure. We'll send a message to our self. So remember that is from the self event, which is here in the palettes or in the project under the jettl utility self event. And we will wire that in here and give it an iterate of 1. I suppose this is just a number, so we'll have to bundle it into the class private data. So this is the message. We send the message to ourselves. It is executed in the message strategy message override. So let's go to that custom message iterate, and here we'll get the reference to the waveform chart that we created earlier. Drop down a property node and have value, not value signaling. I think it's here in the context help. We don't have to, we can read it if you want to read it. You can pause it. Generates a value change event. We only want to change the value of the control, not change the event. Doesn't matter. So iterate, we're just going to wire that up. And we could, if we wanted to, put in the merge. I'm already forgetting if this is the VI or if, oh, merge error VI. That's the message. Merge error, this one. We can merge the error in case there is an error at that point. So when we send ourselves the message, we take that, right now it's hard-coded as a 1. We send that 1 a message to ourself. So we run the app. Oh, it immediately closes. Oh. Uh-huh, uh-huh. Is there an error? Ah, there is. Ah, right. Okay. Iterate once. See, I'm just iterating through. Just. And then I want to turn this auto scale off. That way it's easier for you to see. But you see it's at 40. And then if we were to run it again, it's also at 40. If we run another clone, it starts at 0. Ooh. Now this is where shared clones get tricky, because you have these clones. I could be wrong about this. You have these clones that are spawned when you create them. So we created one clone, we iterated, we're at 49. This clone is at 9. We've created 2 clones. Now create another clone. It starts at 0. Now check this out. If we close, say, these two, will we have one that starts at 0? No. It chooses one of the clones. I don't know how it does it. But see, this is the one at 49. And the other one is at 0? No, it's at 12 from earlier. But if we do a fourth one, now it does start at 0. Or, nah, it starts with no values input, which is default. This still works the same way. Pop-ups. I'll close all these. And the project is not locked in. The library is not locked anymore. So instead of iterate going through, I'm going to put a sign. And just because I have... Wait, is there a divide by 2? Oh, pi divided by 2. Divide by 2 would be cool. Modulo 2. So iterate once. Oh, right. I'm only sending 1, so it's giving me a static value. So let's update this value to give us an actual sine wave with an incrementing value. So we'll go back to the iterate, and we'll take an input. And what we'll need to do from routine is we will take this control and we'll put it in our private data and call it current iteration. And I believe we need a bit more space here. So some more space. I don't like that space. And then I haven't, look at this. This is the human error that I'm talking about. I hadn't even made that control yet, and now I'm losing my train of thought. Oh yeah, and it's not supposed to go there. It's supposed to be the refs. And I have made it, but I just haven't wired it. Oh, the human error. So this is a good case scenario to see how error prone these tasks can be. So iterate once. And then where was I? I already forgot. I was resizing. So, oh right, okay. I resize this to now be an in-place element structure, which takes the current iteration and simply increments. Okay, I'll keep this up, and then take that iteration and go here to the message. Does that make sense? Iterate once. Sine wave. Woo. So every new iteration is being incremented, and then going through that divide by 10, going through the sine wave. So it's the argument, goes into the sine of x, and then is displayed here on the waveform chart. And really, most of the time I don't want to be clicking through. Oh, that's another thing I didn't get back to. We're going to automate this to pump messages to ourselves, is what I'd like to do, so I don't have to continue to click every time. You'll see, now this is at 1, it's also at 1. But if we were to close any of these, it doesn't start at 0, and I'd like it to. So this is a perfect case scenario for changing what's in the setup override. Currently, default value is renet all. Maybe I'm missing something, but for the waveform chart, what you need to do, I think, is get the waveform chart reference and go to the history and make that constant. And I can merge errors. I'm not going to do it for time's sake, really. Also, it won't throw an error. Anyway, every time that we run this, in different instances, see we have 3 clones of different values of iterations. I'm going to exit those two, do the next one. Oh, and it doesn't start over. Why is this? I need to think why this is. Because we send setup to ourself, routine executes, that's good, is nominal. I'm working through the logic in my head. Does setup execute? Have I been deceived? No, because it's, yeah, it has to. This is my debugging. A little dialog box. Setup. So setup has occurred before the panel has been shown, and now OK, panel shows. So setup is going through. We've bundled the references in. Hello, waveform chart. Hello world. Setup. Waveform chart. What? So strange. I must be overlooking something. Am I? Or, no, wouldn't let me run. Oh, nothing. Iterate. What? What am I doing wrong? Oh, maybe... Oh, I suppose... Oh, okay. Actually, nothing's wrong. I'm not resetting the axes. The history is deleting the data, right? So these all have a bit of a waveform. And now if I delete any of them and run them again, the shared clones don't have a waveform, but they start at different axes numbers. So what I could do there is set up change the X scale maximum. Oh gosh. It has been a while since I've used this. It's not important. I concede for now. Nonetheless, it gets rid of the history. So what we should be doing, instead of looking at base LabVIEW, is, sorry, here we are in the iterate. What I want to do is pump a message to ourselves continuously. So I'm going to say auto iterate to automatically iterate. And now I think you could see how pressing of an issue it is to create these controls and me mess up by not wiring them in properly before every time they're used. And it'll make sense in a minute when I use the hidden gem auto iterate. And now instead here, we're going to send ourselves a new message. Called auto iterate. And because it is private, I will change its location on disk, followed by the banner, text being red, so I know it is private, to the containing library, and check out the dead folders to make sure everything moved properly. And I will go to routine, because this is where we will use that. Oh, and of course I reminded myself too, need to change the auto iterate icon, and I will not have an input to this message. So to update the proper icon, we're going to rescript, auto iterate. Now this icon pops up. And now auto iterate, send a message to ourself, to the self event. And when we send it to ourselves, we must be able to implement the messages method. I'm starting to slow down a bit so I can be more conscious of thinking through. Auto iterate. So what happens here is that in the iterate once, it takes the current iteration and increments. But really what I'd like to do is have that functionality be here as well in the auto iterate. So it'll take the current iteration and increment by 1. And do, well, I suppose it's the same thing as iterate. The internals to the iterate. So I could wrap it in a sub VI, or just to make it more simple, instead of writing this all again, I will be smart. And even though this isn't really what iterate does, I will use the iterate method. Remember, these can be reused, and it's encouraged to do so, to execute them in line instead of sending messages to yourself. And then we'll get the current value for the iteration. We could also branch it there, but I'm going to follow data flow. Picky. So every time auto iterate occurs, we will effectively do what iterate does. But what we'd like to do is continue to send that message to ourselves. And I'm going to do it kind of the wrong way. So we're continually going to send auto iterate to ourselves. This is the privacy, which I haven't talked about. Privacy, the priority. If it should jump to the front of the FIFO queue or be a normal messaging queue to the back of the queue. There's just two priorities. So, because we're sending this message, we're executing the message, and then inside sending a message again to execute this message, we're going to be sending it very quick. So I'm going to put a delay of 50 milliseconds, auto iterate to get kick started. And now we can iterate once as normal with the different windows if we'd like. Oh, I meant to click iterate once, but now it's auto iterating. Same here, iterate once, auto iterate, send a string, display hello. Now watch this, display hello, it stops because we're executing the method, and even though the messages they're being enqueued to the FIFO event, they're not being executed, so this isn't updating. This is the dialog box, so it's just in this method, not moving. So even though, well, I suppose, actually, messages aren't continually being streamed because the timing is dependent upon itself. So there isn't anything in the queue here, but it will progress as I hit this. Does that make sense? I'm reasoning it in my head too. And then once any of these are done, you can close them, and they close gracefully. And I suppose I can keep going, but I've outlined a few pieces of core functionality, really what this is, what the jettl events are, messages being private, and this is only a single actor system. When you have the queues, I suppose I won't go into any depth, but you'll see if I open another palette, so you have the create base queue and the queue. Right now these are the events, the event palette. This is the queue palette. Do you see that they are very much the same? They have the same algorithmic determination, almost the same messages. Queues can just create queues and create events, and they have more last acknowledgements to them. And they have the same base functionality. Instead of self-event alias, it's self-queue and self-queue alias. And then, because it's a queue and it can create things, it has this advanced palette as well as over here in the events. And these are mirror images of each other, the same method names. It's just that these have this prefix of creators, because it's your creators created queues. Like I said, I won't go into details here, but this is what leads to distributed design and being able to scale quickly. But yeah, queues, they have a creator, and they can create queues, create events, send messages to all of them, send messages to their queues or their there's too much to talk about. I haven't prepared for this, but the functionality is there. I've tested it. It's great. Yeah, I also want to talk more about the messages. One bug I found too, when I changed where this is in the project, you see this is public, but if you right click it, it's still private. So the access scope doesn't change, it's just the glyph is not correct, but nonetheless it doesn't matter. I want to talk about the message strategy, but this has to be for another video. Actor Framework solved it very well, and this very much is the same. Yes, so much to talk about here, but I will revert to a different video. I think this will end it. Maybe I can keep going with things, but this shows the core tools, the methodology of method execution, messages, the folder structure, the palettes, as well as the utilities. I have a lot more to say too. I designed the library, so a lot of it is in my head, and I have immediate projects that I'm going to be applying this to. I've just waited so that I can finalize just to get this single video out of me yapping and just going through some basics. So if you do like this, I suppose you can like the video. If you have anything that you'd like to add or clarifying things, I know I've left many questions open to be answered, so please do. Either you could leave a comment in the video, or if you want to reach me on LinkedIn or on Discord, on GitHub, please feel free to. This is a project that I see many people benefiting from, and I'd like to contribute back to the community from those who have come before me. This is my spin on what I've learned. So if you have any criticisms of it too, clarifying questions, just let me know. Or maybe somebody else knows, and you can reach out to them. More so, the GitHub. So this is my name, jettl. You can go copy the code. It's not on VIPM yet. I mean, it is, but these are unpublished repositories. Here's the hidden gems. I didn't even use this. Yeah, there's so much more I'd like to talk about. You can clone this down. You can fork. If you star this, that'd be cool too. So I could see that people are locking on to it. And then any criticism, please just send me a message. And probably more importantly, join the Discord too. This is where a lot of discussion goes on. Well, not quite yet. I haven't contributed enough to the Discord, but a few people have joined. So if you'd like to talk to others who potentially use jettl, please do consider joining and then reaching out to me or anybody else with questions. So yeah, thank you for if you got to the end, thanks. Yeah, thank you for watching. Have a good day.